A circle of radius 1 has a square inscribed in it, and the whole region between the circle and the square is shaded. A second circle of radius r also has a square inscribed in it, but only 1/4 of the region between that circle and its square is shaded. The two shaded regions have the same area. What is r? You can pause here and solve the problem before seeing the solution. Here are the two figures. On the left, radius 1, and all of the region between the circle and the square is shaded. On the right, radius r, and only one of the 4 matching pieces is shaded. For any circle of radius r, the inscribed square has diagonal 2r, so its side is r times the square root of 2, and its area is 2r squared. The region between the circle and the square is the circle's area. Pi r squared minus 2r squared, which factors as r squared times pi minus 2. For the first circle, r is 1, so the shaded area is just pi minus 2. For the second circle, the full region is r squared times pi minus 2, and 1/4 of it is shaded, r squared times pi minus 2 over 4. The shaded areas are equal, so r squared times pi minus 2 over 4 equals pi minus 2. Divide both sides by pi minus 2, and r squared over 4 equals 1, so r squared is 4, and r is 2. r equals 2.